Okay, here's another video going over some more derivative examples. We're going to focus on the basics because you really need to have a good grasp of this as we're going to be using the basic derivatives for the next several weeks in the course. Now here we just have a straightforward one. We have 4 breaking down the 5 giving us 20x. 5 minus 4 is, 5 minus 1 is 4. Then 8 times 3 is 24. Subtract 1 from the exponent. Bring down the 2. 3 times 2 is 6. Subtract 1 from the exponent. Plus 8 minus 0. Let's do another example with fractions. Now, in a case like this, I want to rewrite it. Now, the first one, it doesn't matter whether you rewrite it or not, but the second one, we have to bring that x up to the negative 1. But leave the 2 in the denominator. If you bring the 2x all up together to the negative 1, you will probably get the question wrong. It's much easier just to bring the x up. So now we have 6/5 times 2x, derivative of x squared, plus 5/2 times negative x to the negative 2. Simplifying, we get 12x over 5 minus 5 over 2x squared. Here's another example working with roots. Again, one of the first things you should do is rewrite it. So we have 9/4 p to the 1/2 minus 8 p to the negative 3/4. Negative because we brought it up from the denominator. And then 3 over 4. 3 being the power, 4 being the root. Then we can take the derivative. We have 9/4 times 1/2 times p to the negative 1/2 minus 8 times negative 3/4 times p to the negative 7/4. Remember, you're always subtracting 1. So 1 is the same as 4 over 4, so 3 minus 4, or just use your calculator. And then we can simplify. This ends up being 9 over 8 root p plus, this will end up simplifying to 6 over the 4th root of p to the 7th. Here we have an example where we're going to be using the chain rule. So we have 8, bring the exponent down, rewrite the inside, subtract 1 from the exponent, times the derivative of the inside. And then simplify, we get 64, 2x plus 3 cubed. Here we have another example where we're going to be using the chain rule. Now be careful. A lot of people try and use the product rule here, but the only thing multiplied together is the 8 times the 5 minus x squared to the third. So we can take the derivative of each part separately. So the 7x cubed is just 21x squared, and then we use the chain rule to take the derivative of the second part. We bring the 3 down, derivative of the inside, rewrite the inside, subtract 1 from the exponent, then the derivative of the inside. The other big mistake on this one would be forgetting the negative when you take the derivative of the inside. That's negative 2x. Now we need to simplify. 8 times 3 times negative 2 gives us 48. It's now positive. And that would be our final answer. Here's another example where we could use the chain rule and just bring up the denominator to the power of negative 1. Because there's no variable in the numerator, this is why I'm going to use the chain rule. If there's a variable in the numerator, then I would be using the quotient rule. Now we end up with 4 times negative 1. Rewrite the inside. Subtract 1 from the exponent. Derive the inside. Now we can simplify, so we get negative 4, 3x squared plus 2 over x cubed plus 2x squared. And this is all I need you to do to simplify, is just simplify those monomial terms. You don't need to start multiplying things into brackets. That's usually when you start to make mistakes. Here we're going to be doing the product rule. There's a couple different orders you can do it in. I'm going to go derivative of the first, which is 15x squared, rewrite the second, and then plus the first, derivative of the second. And to do the derivative of the second, we're going to be using the chain rule. Don't forget to take the derivative of the inside, and then we can simplify. First one is fine as is. Second one, we need to simplify the 5x cubed times 5 times 8x. That gives me 200x to the fourth. Another one using the product rule. This one we're going to rewrite first because we have a root. This is a cube root, so it's to the power of 1/3. So derivative of the first is 7. Rewrite the second plus the first, derivative of the second using the chain rule. Simplify. We end up with 14t over 3 times the cube root of 2t plus 1 squared. Here's an example where we're going to be using the quotient rule. So we take the derivative of the top, rewrite the bottom, minus the top, derivative of the bottom, over the bottom squared. Then we can simplify. Collect like terms. And we have our final answer. Let's do another quotient rule. So derivative of the top, the bottom, minus the top, derivative of the bottom, over the bottom, all squared. Simplify what you can. We can take a 6, 2x plus 1 squared, and a 3x minus 1 out of each term in the top, leaving me with a 3x minus 1 minus 2x plus 1 all over the bottom to the fourth. Now the reason I common factored the top is it's a little bit easier to see that we can divide out a copy of 3x minus 1. You don't have to do it this way as long as you realize you have to simplify. So we get 6, 2x plus 1 squared. As I said, a copy of 3x minus 1 divides out, leaving us with 3 in the denominator. And then what's inside this bracket we can simplify. We have 3x minus 2x is x, and then minus 1 is negative 2. And that's as far as we can go with this one.